Hello students, welcome to the next lecture on the ordinary differential equation. Today I will explain you how you can learn the concept of ordinary and the singular point. Myself Dr. Harish, you can follow and subscribe my YouTube channel where you can find the playlist of the differential equations. You can see all these lectures related to the first order, second order and their PY questions are already uploaded. You can also see the existence and the uniqueness theorems, various examples, interval of existence and many more lecture are available. तो सिंपल इस प्लेलिस्ट को फॉलो करना है और चैनल को सब्सक्राइब करना है. What is the objective of today's lecture? We will see what is the concept of the ordinary and the singular point for the second order differential equations. Fine. तो जैसा मैं प्रीवियस वीडियो में मैं आपको डायरेक्टली एग्जांपल्स और थ्योरम पे नहीं मूव करूंगा. फर्स्टली आई विल गिव यू अबाउट द मोटिवेशन. फाइन. कैसे आप अपनी डे टू डे लाइफ से इसे कनेक्ट कर सकते हो. नाउ इमेजिन यू आर ड्राइविंग अ कार ऑन अ स्मूथ हाईवे as you can see in this picture. Fine. So now you can see the roads are very smooth. Fine. The road is a perfectly smooth. Then your car is also moving in a very comfortable manner. But what will happen after this point? इस point के बाद तो आगे road आएगी ना. Fine. What will happen after this? After what will happen of the road after this picture? यहाँ पे क्या होगा. मान लो ये एक point है आपके पास. That point is say x naught. इस पॉइंट पे आपकी रोड क्या हो सकती है. इस पॉइंट पे रोड it may be rough, it may be crack or even the more dangerous as you can see in this diagram. Fine. After this picture you can see the some of the side of the road is cracked, but after the few time you can see it's a dangerous region. तो क्या आप अपनी कार को स्मूथली चला सकते हो इन दो कंडीशन में? No. That means you can then your car will be moving comfortably. No. Fine. इसका मतलब क्या होगा कि पहले आप स्मूथ में चल रहे थे. After a certain point, fine, after the certain point your comfortness is disturbed. The same way we can learn the differential equations. Fine. मतलब अगर आपके पास कोई differential equation का solution है, पहले वो initially smooth चल रहा है, after that सब कोई disturb हुआ, फिर वो smooth होना शुरू हो गया, फिर disturb हुआ, फिर smooth हो गया and then so on. Fine. And that's for understanding this smoothness or the unsmoothness. Fine. We are trying to learn the today's concept. For many differential equations, solutions behave nicely in the some regions, but after certain points, solutions behavior suddenly change. और वो solution behavior कैसा हो सकता है? It may be becomes infinite, it may oscillate widely, or after some times or at some points it fail to exist in the usual form. So that means the solutions, the equations becomes normally at some times where it becomes probabilistic. Fine. So to understand what will happen when it will be the normally or when the differential equation will create a probabilistic. So to understand the concept, we are trying to learn the concept of ordinary and the singular points. Clear? समझ में आ गया ऑर्डिनरी सिंगुलर पॉइंट का क्या यूज है. अगर आप एक कंफर्ट जोन में हो लेकिन आपको कोई डिस्टर्ब करे तो वो डिस्टर्बिंग पॉइंट जो आएगा आपके पास उस पॉइंट को चेक करेंगे whether the point is my ordinary point or the singular point. The concept of the ordinary and the singular points is very important while solving the differential equations, because whenever you have any kind of the differential equation, what is your target? Your target is to get the solutions. Then how you can get the solution of any differential equations? We always have the three methods. The first one is the power series method, second is the Frobenius method, and the third one is the special functions like Bessel, Lysander, Hermite, and so on. How we can distinguish between them? They are basically depending upon whether your point is ordinary or your point is singular. Based on the nature of the point, we can discretize the power method, Frobenius methods, and the special functions. So consider the differential equations of the second order. Make sure whenever you consider the second order differential equation, the coefficient of the y double dash must be 1 and p and q must be function of the x only. They are the functions of the x only. Fine. Then you can say whatever the solution of the equation number 1, that totally dependent upon the behavior of the px and qx. Fine. अगर मैं ये कह दूं कि px and qx both are my continuous, both are continuous for all those x belongs to the some interval I. Find some interval I, that implies there is existence of the guarantee of the solution. Find in the interval I. इस इंटरवल I के अंदर आपकी गारंटी होगी सॉल्यूशन की. इस इंटरवल के बाहर क्या होगा, अंदर बाहर क्या होगा, वी हैव नो गारंटी फॉर दैट. Fine. That is the existence and the uniqueness one. But what is the nature of the solutions? Whether the solution will be finite or whether it is my unbounded, fine, or it becomes oscillate, that will depend upon the behavior of the px and the qx. But before I try to understand the solution of the differential equation, there is a need of the one concept. That concept is called as the analytic function. Any function fx is said to be analytic, at the point say x is equal to x naught. कब कह सकते हो किसी भी पॉइंट को एनालिटिक और किसी भी फंक्शन को एनालिटिक? एक पॉइंट पे, व्हेन यू कैलकुलेट द लिमिट ऑफ द फंक्शन fx as x approaches to the x naught, if this limit is my finite and existence. Fine. Existence का मतलब uniqueness. Fine. If this limit is finite and existence, then you can say the function is analytic. Fine. Or in other words, we all know what is the meaning of the analytic. That means continuously and differentiable functions. Once you know the function is continuous and differentiable, so then you can write any function fx with the help of the Taylor series. Fine. Taylor series means you can expand in terms of the power series. That means, in other words, any function fx is said to be analytic if you can write in terms of the Taylor series. Fine. And the Taylor series is existence and convergence to the fx. Now we can define the concept of the ordinary point. Any point fx is said to be the ordinary, any point x is equal to x naught is said to be the ordinary point of the differential equations if px and qx both must be analytic. Both must be analytic. किस पॉइंट पे? At the point x is equal to x naught. Both, remember. और analytic का मतलब क्या है? That means you can find the limit as x approaches x naught of the px. It must be finite and exist. Similarly for the qx, limit x approaches x naught of the qx is my finite and existence. Fine. और इसका क्या मतलब होगा? Once the both the p and q are my finite, or that means you can apply the Taylor methods, or in other words you can say the px and qx do not blow up. Blow का मतलब infinity. ये infinity पे इसकी value नहीं जाएगी. Fine. That means the coefficients must be do not blow up. Once the point is my ordinary, then the solutions or the equation behave smoothly, and once the point is your ordinary, then you can always apply the power series method. मैंने स्टार्टिंग में आपको 3 मेथड बताए थे ना. First one is the power series method, second one is the Frobenius series method, third one is the special functions like Bessel's and so on. And whenever you have proved that the point is ordinary, that means you can apply the power series method. और जो मैंने आपको स्टार्टिंग में कार वाली एग्जांपल दी थी, द ऑर्डिनरी पॉइंट मींस यू आर ड्राइविंग अ कार ऑन अ वेरी स्मूथ रोड. फाइन. मैं रिकॉल करवा दे रहा हूं आपको. वाई डबल प्राइम का कोएफिशिएंट मस्ट बी 1. फॉर एग्जांपल, consider the differential equations and you can see the coefficient of the y double prime is not a 1, so you can firstly make them as a 1. So if you compare them, what is the px will be x over 1 plus x square and qx will be 1 over 1 plus x square. Is it fine? Now if I want to check at the point, say any point, say 0, what is the px at the point 0? Px approaches to the 0 and qx will approaches to the 1. Both are my finite and unique. Fine. So what does it mean? That means x is equal to 0 is my ordinary point. On the other hand, if you want to check at the point say x is equal to 1, what will happen? P of x will becomes my 1 by 2, q of x becomes my again 1 by 2. Both the limits are my existence and finite. Therefore, x equal to 1 is also my ordinary point. Clear? Moreover, can you find any of the x? Can you find any of the x naught so that p of x, either px will goes to the infinity or qx will goes to the infinity? क्या कोई आपको ऐसा पॉइंट मिलेगा इसमें? कभी नहीं मिलेगा. That means what is the meaning of that? That differential equation, every point for all x belongs to the R is my ordinary point. Is it okay? Now, second definition is the singular point. Any point is said to be the singular if either px or qx. Ordinary point किसको कहते थे? Whenever p and q must be analytic. तो यहाँ पे क्या हो जाएगा? Either p or q are not analytic. Fine. Analytic का मतलब नहीं, analytic का मतलब लिमिट जो आपके पास क्या हो जाए, इंफिनिटी हो जाए और अनडिफाइंड हो जाए. यही तो थी ना. Either both p or q. That means if you find the limit of the px as x approaches x naught, either this limit or limit of the qx are either infinite or not a unique or undefined. Again, make sure the coefficient must be 1. That means the system break down after at some point. Singular points are appear very commonly in our day-to-day life, like of the wave propagations, quantum mechanics, and so on. और अगर आप साइंस के स्टूडेंट्स हो, you must heard about the resonance frequency. Omega square is 1 over LC. Behavior near the center of the circles, near the black holes, all are the points of the singular points. Now, the example of the singular point is if you consider the differential equations, your first target is to make the coefficient of the y double prime to be 1. If you compare the given differential equations with the standard second order differential equation, what is the value of the p and q? P of x is 1 by x, q of x is again 1 by x. Fine. And if your target is to check the behavior at x is equal to 1, what will happen? Px will approaches to the 1, qx approaches to the 1. Both are my finite. Therefore, x is equal to 1 is my ordinary point. But if you want to check at the point x is equal to 0, तो px कितना हो जाएगा? Px will goes to the infinity. Fine. तो जैसे ही infinity गया, that means the function is not analytic at the point x is equal to 0. Therefore, x is equal to 0 is my singular point. Why the singular points are important? First of all, as we know, the singular point means the function is not analytic. Fine. Once the function is not analytic, that means you can never write in the terms of the Taylor series. Fine. If it is not right in the terms of the Taylor series, that means you can never write the solutions in terms of the power series method. तो इसका मतलब जो हमने ordinary point में देखा था, ordinary point होगा तो आप solution कैसे निकालोगे? By using the power series method. But whenever the point is singular, power series method is not applicable. That means the solution becomes unbounded, power series method may fail, and so on. So whenever the point is singular, we can always apply our second method, that is called as the Frobenius series method. Fine. Now there are the two kinds of the singular points depending upon how badly the coefficients blow up. That is a regular or the irregular singular point. As I mentioned you, whenever you have the singular point, you can always apply the Frobenius series method. If I say x is equal to x naught, if I consider x is equal to x naught is my singular point, fine. सबसे पहले आपको singular point prove करना होगा, and then you can check whether the point singular is called as irregular or the regular. The concept is very simple. You have to check x माइनस एक्स नॉट, जिस भी पॉइंट पे बात करेंगे, इंटू पी एक्स कोफिशिएंट ऑफ द वाई प्राइम एंड x माइनस एक्स नॉट स्क्वायर ऑफ द क्यू एक्स। अगर तो ये दोनों के दोनों आपके एनालिटिक आ गए, एनालिटिक का मतलब क्या है, इन दोनों की लिमिट क्या हो जाएगी, फाइनाइट, देन यू कैन से इट्स अ रेगुलर सिंगुलर पॉइंट। अगर इन दोनों में से किसी एक की भी लिमिट एग्जिस्ट नहीं करी, देन वी कॉल एज द irregular singular point. That means whenever the limit of the x minus x naught of px and x minus x naught is finite, that means both are analytic, then we call as a regular singular point. Otherwise, if either or both is not exist, we call as the irregular singular point. जैसे if I look at the same example, x double prime plus xy prime, fine, plus or simply you can say plus y is equal to 0, fine. So you can find the value of the y double prime 1 over x y prime plus 1 over x of y. Now clearly say these are my p and q. Clearly say x is equal to 0 is my singular point, fine. Now your target is to check whether the singular point is regular or irregular. I can found the limit x minus 0 into px. Px will be 1 by x as x approaches 0. कितना आंसर आ गया, 1. On the other hand, if I calculate x minus 0 square into qx, so the limit will be 0. Fine. Clearly say both the limits are my existence. Hence, the x is equal to 0 is my regular singular point. क्लियर। और अगर ये लिमिट दोनों में से किसी एक की इंफिनिटी आ जाती है या डज नॉट एग्जिस्ट, देन वी कॉल एज द इरेगुलर सिंगुलर पॉइंट। मैं आपको 15 प्लस एग्जांपल्स वाला एक लेक्चर भी आपको अपलोड करूंगा जो सिर्फ ऑर्डिनरी एंड सिंगुलर पॉइंट पे होगा। So that means you can say any point is either the ordinary or the singular. If it is singular, then again it divided into the two categories, regular and irregular. What are the features? Whenever the point is my ordinary, then you can always apply these solutions. कौन सा method के साथ होगा? That is the power series methods. Fine. And whenever you have applied the power series method, then we can always get the convergence with the help of radius of convergence. And the characteristics is solution is always be well behaved because the px and qx both are my analytic. On the other hand, any point is said to be the singular. सिंगुलर में भी इसको रेगुलर बोल देते हैं। उसका मतलब क्या होगा, आपके पास कौन सा मेथड अप्लाई होगा, दैट मीन्स वी कैन अप्लाई द फ्रॉबनियस सीरीज मेथड्स, मेथड वी कैन अप्लाई एज द फ्रॉबनियस मेथड्स। और बिहेवियर क्या होगा, सॉल्यूशन को आप बाउंडेड बना सकते हो बाय यूजिंग सम एल्जेब्रिक फंक्शंस। बट अगर आपके पास इरेगुलर सिंगुलर पॉइंट है, फाइन, दैट मीन्स यू कैन नेवर फाइंड द सॉल्यूशन, we can never find the solutions. Solution is always the divergence, convergence there is no guarantee, and the Frobenius method is not applicable. If I summary them, what will happen if feature p and q ordinary point means the function must be analytic. तो अगर p and q are analytic है तो ये भी आपका analytic होगा, fine, all are my analytic. लेकिन अगर सिंगुलर पॉइंट है, p and q are either one of them is not analytic, that means diverge, fine. लेकिन whenever you can multiply x minus x naught, regular means the limit must be finite, finite means that it is my analytic, but in these both the cases it is my divergence. Whenever the point is the ordinary, you can always apply the power series method. When the point is a regular singular, you can apply the Frobenius method, and for the irregular we can never find the solutions. क्लियर। अगर आप चाहते हो कि मैं 15 प्लस एग्जांपल्स इन तीनों मेथड्स, तीनों पॉइंट्स के ऊपर अपलोड करूं, लेट मी नो इन द कमेंट बॉक्स, आई विल अपलोड द नेक्स्ट लेक्चर 15 प्लस एग्जांपल्स ओनली फॉर ऑल ऑफ यू. Till then, you can share this video with your friends, like and comment on the videos. Best of luck, students. Happy learning always.